Welcome back. What you're looking at here is a servo motor from a Russian Geran drone. I bought this through eBay for a small museum that I have that looks at the history of aviation with various artifacts from different aircraft, illustrating changes in technology. The most common drone used in the Russo-Ukrainian war is the Geran-3. This design comes from Iran, where it's called the Shahed 136. In Farsi, Shahed means witness. The type of drone was also used in the war, where the United States and Israel attacked Iran in 2026. The Shahed 136 was first produced in 2021. It was sold to Russia, who then got the rights to manufacture it there, and it's manufactured in large numbers. In Russia, it's called the Geran. The word Geran comes from the word geranium, which is a plant. And the Geran-1 was another delta wing-shaped drone. It's a little bit smaller than the Geran-2, which is powered by the Mado MDE 550. That's basically a reverse-engineered Limbark L550E, and Russia's now producing its own version of the engine. This servo here is off the Geran-3, which is the same as the Shahed 238. It's powered by a Chinese Telefly JT80 jet engine. So both the Geran-2 and 3 are 3.5 meters long. They've got a wingspan of 2.5 meters. And they're basically one-way or suicide drones that can fly well over 1,500 kilometers. Depending on the weight of the warhead, which can be up to 50 to 90 kilograms. Total weight is 200 kgs. The drone could be launched from a pickup truck driving at speed, or it could be launched from racks in a larger truck where it uses a small rocket motor to get it up to flying speed before the rocket drops off. The servo here, as I mentioned, is from the Geran-3, the jet-powered version. And it's one of four that control the elevons. So the elevons, the control surfaces at the back of the aircraft. And like all drones, it has a flight controller, an air data sensor, as well as a GPS for navigation. The target is programmed into the drone, and then the flight controller steers the drone to the target at a predetermined altitude and route. And the job of the servos is basically just to control that altitude and the direction. It sits in the fuselage and it's attached to the elevons via a control rod. So when it gets to the target, the drone dives down and explodes. Now, fortunately for Ukraine, this drone never got to the target, as it was shot down near the village of Chebaki. When it was listed on eBay, it was described as it may not be working, as I found it in water in a wing fragment. So yeah, it didn't have a lot of hope of actually being able to make it work again. But I looked online and I found that this particular servo was made in China by the Dongguan Gongshan Power Technology Company. And on their website, they said it was waterproof. So on the basis of that, I did have a little bit of hope that I'd be able to get it going again. So I pulled the back of the servo apart, and inside I did find some moisture. So my expectations went down a bit at that point, but I ran a multimeter across the various points inside, and it came with the cable that you see here. So by putting the multimeter also on the pins at this end, I found the power, earth, and the pulse width modulation pins. So I've connected that up to an Arduino here. The pulse width modulation goes into pin 9. And the power goes into the VIN. The servo in the aircraft would have been powered by about 12 volts. The Arduino is normally 5 volts if run off the computer, but you can put a 9 volt power source on it, which is what I've got here. And basically online it said that the VIN may put out a bit more than the 5 volt. So I thought that was a better option for powering up the servo. So anyway, I wired it all up, and after doing a wiring diagram, and it worked, so much to my surprise. So I'll put up here the code that I've used in the Arduino, and you can pause the video if you want to write that down. and I'll also put up the wiring diagram, and again you can pause the video to draw that and replicate what I've done here if you wish. So now I'll put up the video showing it working as I move a potentiometer which I've attached, and you can see the movement left and right. The servo goes for about 170 degrees. So yeah, all functioning and all working, much to my surprise. So probably the toughest part of the Geran drones is the servo motor. So I hope you enjoyed the video. If you did, click the like button and we'll see you back again for the next one.